Welcome back to another episode. For today's topic, we will dive into some string processing as we will treat Matchsticks, the problem from Advent of Code 2015, Day 8. We're told that space on the sleigh is limited this year, so Santa will bring his list digitally. For this, he needs to know how much space it will take when stored. However, the strings on his lists contain various escape characters. Escape characters allow you to indicate that a character should be treated differently in a string. Typically, we use a backslash for this. So, when we want to have a string contain one backslash, then we need to type two backslashes. If we want to escape a double quote, then we write backslash double quote. Finally, we can escape characters which are represented by some hexadecimal code. These are prefixed by backslash x, followed by two characters from the range of 0 to F. If we disregard all the white space in the file, then our question is as follows. What is the total number of characters of code for all string literals minus the number of characters in memory for the values of all strings? Let's take a look at some examples. First, the minimal example. We're presented with two double quotes. This is two characters of code, but the string literal itself actually contains 0 characters. Here we have an example with 5 characters of code, but it only contains A, B, and C, which is 3 characters of string data. In the next example, we see the first occurrence of an escape character. We have 10 characters of code, but 6 A characters and 1 escape double quote, which makes for a total of 7. Here we see 1 escaped hex character. So there's 6 characters of code needed to represent this single character. Now, if we take them all together, then we will find that there were a total of 23 characters in all string literals together. However, the total number of actual string characters in memory was only 11. Hence, the answer that we would give is 12. Maybe you already see how you can implement this, but for a final tip, consider that a backslash always initiates an escape. When you are ready, let's take a look at the solution, but do feel free to pause the video and give it a shot yourself first. The first part is really straightforward. We need to know the total number of characters in the string literals. This Python code shows a way to get all the lines of input which you can get from adventofcode.com. Please go there to get your own input for today's problem. When getting the input, we make sure to strip any white space, and then we simply sum all lengths together. The second part requires us to compute the total number of in-memory characters. This is something we can do by passing over every string in the input once, and we do so character by character. In the code below, we first take a line from our input, and we remove the first and last double quote. Then we start at the beginning, and we put our pointer, denoted by index I, at 0. While our index is less than the length of the line, we know that we shall take in a character, and we increment count by 1. Then we check the character at our current index. Is this character a backslash? Then we know that a character is being escaped. Do note that in this Python code we write double backslash ourselves, because of course our code needs to escape the backslash. Now, if we know that we are going to escape a character, then there are only 2 options left. Either we escape a backslash or double quote, or we are escaping a hex character. A backslash or double quote then means that we can skip a character in our input, and we increment our pointer by 2. In the case of a hex character, we know that such a character always consists of 4 characters, so we increment by 4. Now you might wonder why we don't explicitly check if the hex character is valid. Simply put, this comes down to the fact that a backslash always escapes something. Given the constraints of the problem, we know it must be one of only 3 options, and when we get to the case of the hex character, we already ruled out 2. In the case that we did not find a backslash, then we simply found a regular character. We only have to increment our pointer by 1. And that's it already. If we do this for all lines and sum the count variable for each of these, then we can subtract the value from the total number of characters which we computed in the first step. In Part 2 of today's problem, we are asked to do the opposite as Part 1. We're still looking to find the number of characters in code, but we should encode each string literal into a new string that includes double quotes. The question then becomes, what is the number of characters needed to represent the newly encoded strings minus the number of characters of code in each original string literal? Let's look at an example again. Again, we have the minimal case of just 2 double quotes. We shall encode this into a new string, so we need a double quote at the start and at the end, and then we need to escape the 2 double quotes of the original string. We do that by inserting 2 backslashes in front of them. This increases the number of characters from 2 to 6. Here is a slightly more complicated example with a hex character. Again, we need the outer quotes. Then every quote in the original literal needs to be escaped. Since there's a backslash in the literal, this also needs to be escaped with an additional backslash. As a result, the number of characters increases from 6 to 11. For this solution, we again have 2 parts. First, we count the total number of characters in the same way as we did for Part 1. Then we need to parse every line and transform it into the newly encoded string. Although we could count characters and compute the answer that way, let's iterate character by character using I as a pointer again. For every character that we see, we check if it is a character which should be escaped. Now, what were these characters? Only the backslash character and the double quote. So every time that we encounter one of them, we add either double backslash or backslash double quote to our new line. After we are done iterating, the length of the new line is our answer. Just don't forget that the new line needs to have an opening and closing double quote as well. And that's it already again. We have 2 more stars as we venture through the problems of 2015. Thank you for sticking around and see you next time.